Tim, it is all yours now.
All right. Thanks, Jason. Appreciate the introduction, everybody. I appreciate you taking time out from your lunch hour or whatever time it is for you around the world. Like Jason said, we're going to be talking about SQL Server Integration Services in the cloud, and yes, they can get along. We'll be talking about some of the ways that you can use integration services on-prem to touch the cloud, actually run SSIS on the cloud, and interact with different cloud data sources. And then a new and exciting development in the world of integration services where you can actually run your SSIS packages as a platform as a service application directly in the cloud. So a little bit about me. My name is Tim Mitchell. I'm a principal with a company called Tyler's Data Solutions in the Dallas, Texas area. I specialize in integration services, data warehousing, SQL Server reporting services, and generally anything that touches business intelligence or anything on the fringes of that. My contact information is down there. Some of the things that I've done are over on the right. Just a logistical thing. I was talking to Jason a little bit earlier. I'm just getting over a bit of a cold, so if you hear me go silent for a minute, it's probably a mute/cough break. So hopefully you'll bear with me on that. So our agenda, first of all, we'll talk a little bit about the SSIS on-prem story. So more than likely, all of you are at least familiar with integration services. You know what it does. You could create a basic package, but we'll go over a basic overview of how it runs on-prem. We'll talk a little bit about some hybrid scenarios where, from an ETL perspective, we're interacting somehow between local on-prem data and the cloud, either getting data from, writing data to the cloud, or possibly interacting purely in the cloud. We'll talk a little bit about what our options are for actually running integration services up in the cloud. On the development side, we'll talk about the Azure Feature Pack and a piece that you can install into Visual Studio that will let you interact with more than just tables and things like that, but touch some of the cloud-specific and big data components that you might need to use in the cloud. We'll briefly talk about how does SSIS compare with Azure Data Factory, and finally we'll talk about what an SSIS package looks like when running on ADF or actually residing on an Azure DB instance. So by way of overview, integration services was first released in 2005. I replaced data transformation services. For most anything that you need to do on-prem, whether it was a database, an Access database, a file, an FTP file, or whatnot, it had all the connectors for those. And for some remote connectivity, if you needed to reach out and grab data from what we now call a cloud source or cloud destination, it did have some limited support for that. As long as it could just talk to it as a regular data connection, it would do that. But for the most part, it was really unaware of any cloud-based sources or destinations. In terms of on-prem, most of your architecture looks like this. You'll build your SSIS packages directly in Visual Studio, or what we call SQL Server Data Tools, or BIDS if you're using older versions. The packages and the projects are stored directly on the server in the SSIS DB catalog database. And then the packages are executed on the same server where they're stored. So whether you're running a package locally or in an Azure VM, this is typically what your architecture will look like. Package storage options that we have for any deployed instance, either deploy it to the SSIS DB catalog, which is far and away the most popular and the most easy way to do it. For older versions of SSIS, you could also store in the MSDB database or in the file system. Technically, you can still do that with newer versions, but again, there's a lot of advantages to actually putting it in the SSIS catalog. But in all this around SSIS, it really predates the meteoric rise of the cloud. So we look at the cloud as really having come into its own and becoming something that businesses look at for data storage and processing in the last decade or so. Integration services has been around for longer than that. So the early versions, again, they did have implicitly some cloud connectivity options, but they weren't really geared for the cloud. They weren't really built for that. Oh, and it looks like my mouse has gotten away from me. Sorry about that. Bear with me for one quick second. There we go. So the modern versions, and I call modern versions 2012 and newer. Those do have some cloud support. Some of it's built in. Some of it you actually have to install as separate plugins, and we'll talk about that a little more in just a bit. But for the most part, your SSIS packages will still only run on a properly installed version of integration services. What I mean by that is you go through the installation process, you get the ISO, you get the executable, and you install SQL Server and you run the packages on that version of SQL Server. We have an asterisk there because there is some new behavior. It's not released for regular consumption yet. It's still very much in preview. But there's some new behaviors that I'll go over a little later in the presentation that will show you how actually to run SSIS packages on ADF or Azure Data Factory. So some of the hybrid scenarios that you need to account for when you're working with integration services and on-prem versus cloud data. The modern architectures, almost every organization will have some flavor of cloud data and on-prem data. The architectures that will come into play, PaaS or PaaS is oftenly called, Platform as a Service. That's like your Azure Sequel Dw, Azure SQL Data Warehouse. Infrastructure as a Service is like building a VM, building a virtual machine in Azure or some other platform. Software as a Service, a little more abstracted than that, where it's just a software that's offered up. It's a little more of a higher level. And then finally, on-premises. Now, most organizations, as I mentioned earlier, they don't have all their eggs in any one of these baskets. Most organizations do a lot with on-prem and a little bit with PaaS or maybe a little bit with IaaS. So any ETL process has to take into account how to get data from on-prem to the cloud or how to work with both PaaS and IaaS data sources. So within SQL Server, you can see that for the BI stack, we haven't yet gotten everything that we can run on-prem into a PaaS offering, a platform as a service offering. So certainly SQL Server is the most mature product in that offering. We've had Azure SQL Database and SQL Data Warehouse around for several years. Analysis Services is relatively new in that field, so you can now run Azure Analysis Services in a platform as a service without having to have a proper virtual machine. Still coming up, I won't call it a little bit short. I think this is by design, but still not yet fully baked into the platform as a service stack for Microsoft is both integration services and reporting services. Now we've seen some movement on reporting, or rather on integration services, where the new preview version I mentioned earlier does have some capabilities to run as a PaaS service, but for right now, reporting services hasn't yet fully baked in on that. So every hybrid architecture, whether you've got half your infrastructure in the cloud, half of it on-prem, or some fraction of it, you're still going to have to move data. The rumors of ETL being dead are far from being true, so you still need to move data from cloud to on-prem and back. And increasingly, you have to have that as a very hybrid option. So you're no longer just moving data from server 1 to server 2 on-prem. It's very much a hybrid scenario. And the tool that you choose, whether it's SSIS or something else, has to be able to support those hybrid load scenarios. So one of the load scenarios, or one of the architectures that we see, and this is the one that I see most frequently, is if you're interacting with both local and in the cloud data sources, is to run integration services locally on a machine that you control on-prem, and then interact with your cloud data sources from there. So SSIS, in all these scenarios, SSIS is the centerpiece for all the ETL pieces. But in this case, pardon me, in this case, integration services are running on-prem. It will natively communicate with all your sources on-prem, whether it's a secure FTP server, a SQL Server database server, a file share, what have you. And it natively uses the pieces already baked in and mature in integration services to communicate with those data sources. Separately, it can reach out to your cloud data sources as well. Write data to Blob storage, Azure Blob storage, write data to Azure Sequel Dw, whatever you're running in the cloud, it can, with the pieces it's got baked in or supplemental tools that you can download, it can communicate with most any cloud source and destination out there. But this is the most common way to run integration services. Has a number of distinct advantages in running integration services on-prem, including most everything that you'll need to connect to will just be a native connection. So if you're connecting to an FTP file, if you're connecting to a file share, SQL Server, even some fringe databases, as long as there's a driver for it, you really don't have to have any special connectivity pieces to be able to connect there. Send and receive to and from most cloud connections. Again, as long as there's a driver for it, you don't have to write custom code to go out and either write or retrieve that data from the cloud connections. One of the big advantages that you have in running your SQL Server or your integration services server on-prem is that you own that machine. So you own the operating system, you own everything that needs to be installed in there, you have complete control over. That's a bit of a blessing and a curse because while you have complete control over it, you also have complete responsibility over it. So, so you get to install all the third-party utilities you need on it, any monitoring software. Also, you have to patch it. You're responsible for all of that. So again, that's a bit of a double-edged sword. And same thing with the last bullet. You can use Integration Services Server for other purposes. I'm not a big fan of this necessarily, but I realize that because if you're running this on-prem, if you're running SSIS, you're buying hardware, you're buying a SQL Server license, so you want to get the most bang for your buck out of that. At the same time, I've seen a lot of SSIS servers that just because of the other things that are running on them, whether it's DNS or web server or reporting services, they can get overwhelmed and not able to run the SSIS package as well. But again, consider that a bit of a blessing and a curse because you can repurpose that server for other things when it's not heavily running SSIS. But at the same time, you can draw from the SSIS resources and actually slow down your packages in that case. So that is the most common scenario. Running it on-prem, Integration Services supports that really well. So let's talk about how you run SSIS in the cloud. The most common way if you're running Integration Services in the cloud, at least today, is to run it as an IaaS service or running it on a virtual machine. Most commonly, you can run it on an Azure virtual machine, but you could branch out and do it on some other vendor if you prefer some other vendor's virtual machine. It does require the installed version of SQL Server. So you're putting in the disk for those who still use disks, or you're putting in the media or dropping on the ISO file and actually running the installation of SQL Server to be able to run integration services on a cloud-based virtual machine. Just like on-prem, everything is just a connection. So if you're connecting to an Azure database, if you're connecting to an Amazon RDS instance, it's just another connection. For that matter, SSIS doesn't really care what type of connection it is. As long as it has a driver for it, it'll simply connect up to it and consume that data. Same type of thing with remote services if you're using web services or FTP. You'll notice that I've artfully dodged the topic of SFTP. Curiously enough, Integration Services still doesn't natively support secure FTP operations. It does have a driver, it does have a task to be able to get and put FTP files, but curiously enough, it doesn't have anything to do SFTP. Check my blog. I've actually blogged about how to create your own. It does take a little bit of legwork, but how to create your own, I've got a blog about that that I blogged about maybe a year ago or so. So use case of running SSIS in a VM. So this looks a lot like running it on-prem, except that we're shifting that workload from an on-prem server, and now SSIS is running in a SQL server, not on-prem, but actually in the cloud. So SSIS still remains the centerpiece of all of our loads. The big difference here is that if you're running SSIS in the cloud, hopefully your organization is not set up where your SQL Server, your other data sources are simply exposed to the internet. Hopefully they're behind some sort of a firewall that prohibit all but the most specific authorized traffic to come through there. So in most cases, if you are using SSIS in an Azure VM or some other vendor's VM, you have some sort of a VPN or gateway to be able to pass that traffic through without simply exposing all your on-prem data connections or all your on-prem data sources to anyone who comes along doing a port scan. Bottom line is that this piece or this architecture does take a little bit of extra work because unlike using SSIS on-prem, you do have to create that VPN or some sort of gateway to be able to pass that data from cloud sources back into on-prem. I don't see this architecture a lot, so this is probably a single-digit percentage of the clients that I work with use something like this. but this architecture is certainly on the rise, because if you're running SSIS, if you're only running your loads once a week, once a month, or even once a day, you don't necessarily need to be paying for that hardware on-prem, paying for that license 24/7 when you're using it 4 or 5 hours a day. So I see this design pattern on the rise where more and more organizations are creating their SSIS servers as virtual machines and then spinning them up incrementally as needed. Once they're not needed anymore, go ahead and spin them back down. If you're on a pay-by-the-hour plan, which is pretty easy to set up, you're not paying for hardware 24/7 or licensing 24/7. You're only paying for that time slice that you're actually using. So when you're running SSIS in the cloud, a couple of different authentication options. The simplest and easiest to set up is simply using the username and password combination. It's also the hardest to manage from an enterprise perspective, because if you've got one server that you're managing, it's pretty easy to manage a username and password. But most organizations that can afford pros like us don't have one server. They've got 10 or 50 or 100 different servers. So you don't want to have username and passwords on every one of those. The harder one to set up, at least up front, but the easier one to manage down the road is Azure Active Directory. If you're using your Azure AD credentials, instead of forcing that to use a username and password combination, again, it'll take more work up front to set up. It's going to involve more than just BI professionals. It's going to involve your Active Directory people getting involved with that. But it's certainly, in the long run, it's certainly easier to manage that downstream. So your networking, we could probably spend 2 hours just talking about networking on here, but basically, if you're running in the cloud, you're going to have logical networking where you've got a group within Azure. You've got a networking group that you collectively pull together assets into a single logical network. Pardon me. You'll also have bridge networks where if you've got a network for one business unit or for one geographical unit, you can bridge together those networks and allow SSIS servers and other SQL servers to talk across those bridges if those are logically separated. And then finally, as I briefly mentioned earlier, if you need, in the cloud, you need to talk back to something on-prem, you'll have to have some sort of a connector or VPN set up, because you don't want to have those assets exposed from on-prem to anybody who comes along on the internet. And this doesn't require, so I talk a lot about this from an Azure perspective, doesn't necessarily require Azure. Everything that I'm talking about, or everything that I have talked about up to this point, could be run in the Google Cloud. It could be run in RDS or Amazon's cloud. So it doesn't necessarily require Azure running SQL Server. You could create a VM in basically any cloud provider and do this. It's certainly easier in Azure. I've tinkered with the other vendors in doing something like this. It may be because I know Azure better than Amazon or Google or the other clouds that are available, but I've found it's a whole lot easier to do what I'm talking about in Azure than in other providers. The management and administration, so your integration services server is another SQL server, so it requires care and feeding just like anything else. It has to be backed up, it has to be optimized, but the good thing is if you're running it in the cloud as a virtual machine, it looks almost identical to what you would do on-prem. You're going to have a backup schedule. You're going to have your development tools are going to reach out to that local SSIS instance as well as anything that touches. So the learning curve is pretty short, as is the deployment process, because you're simply deploying to another SQL server, whether it's an on-prem SSIS server or an SSIS server in the cloud. It's simply a destination to which you're writing your packages and then running them and managing them from there. But all the same rules apply. Make absolutely sure that you're backing it up, you're checking your index for fragmentation. Periodically, you'll have to purge your SSIS logs, especially if you're running a large number of packages. Your log database could become very large. So make sure that you're paying attention to that in much the same way that you would do for an on-prem SSIS server. Some of the advantages that you have if you're running it in a VM in the cloud, it can literally be up and running in minutes. I configured, actually in preparation for this talk today, I had destroyed one of my virtual machines that I used last time for this talk, and I was up and running in maybe 15 minutes, walk through the process, specify what I want on that server, and it was up and running in no time. From a cost perspective and a scale perspective, you can spin up, either scale up or scale out as needed, and either scale down or power off when you're done. One of the things that I'll show you when we get into the demos is you can take a PowerShell script, for example, and if you want to either scale up your machines, or what I'll show you in the script, if you want to scale out and have multiple SSIS machines running at any given time, you can easily do that with a PowerShell script, spin up 1 to n number of machines, however many you need for that execution, and then once you're done, spin those down. If you're doing the pay-by-the-hour licensing feature, you're only paying for that the licensing and the hardware utilization that you're using whenever you're running those packages, and it's not costing you money 24/7. One thing that we won't explicitly talk about, I want to make you aware that if you're running SSIS 2017, there is a new scale-out feature whereby instead of having, let's say you have 5 SSIS servers or 5 servers running SSIS packages. In version 2014 and earlier, if you wanted to be able to scale those out, you need to take this package from source control and deploy it to server 1, deploy it to server 2, and so on and so forth to n number of servers. If you're using the scale-out feature in 2017, you can basically make an SSIS installation a partner or a scale-out partner of some parent SSIS package. So in effect, that SSIS installation that you're running isn't necessarily the master copy, and it doesn't have to have a duplicate copy of everything. But effectively, that scale-out is just reaching out to individual SSIS servers that you power on as needed, and pass those jobs off to those SSIS servers that are responding. Again, we could spend an entire presentation just on that piece, but do be aware, for those of you, I know 2017 isn't fully taken off yet, just as far as adoption goes, but for those of you who are running 2017 or you're looking to 2017, what I'll show you on scaling out will be especially applicable because you'll be able to use SSIS in a scale out rather than having redundant copies of SSIS running on multiple machines. So that's on the server side. Let's talk a little bit about the tooling on the Visual Studio side and how we can use some of the pieces built in and some of the extra pieces that are available for integration services to reach out and touch some of those cloud endpoints. So things like an Azure Blob, data lake, pig, and hive tasks, and then interacting with an Azure SQL Data warehouse. You could natively do that using the in-the-box pieces of integration services, but there is a feature pack that it'll actually build in some tasks and components that are specific to those pieces and actually make it a lot easier to interact with those cloud-based endpoints. That download is available for SSIS 2012 and newer. It is a free download from Microsoft. I believe I've got that linked in the slide deck at the end. If not, I'll make sure and add that before I send that to Jason for upload. But it's, again, a free download, and it's available for all those versions. Honestly, I wish it was part of the core installation because those pieces are going to be in increasing use in integration services. But for right now, you do have to go through and actually download that Azure feature pack separately. So one of the questions that I get very often is, how does SSIS compare to ADF or Azure Data Factory? Isn't ADF just SSIS in the cloud? The answer is a resounding no. ADF is definitely not SSIS in the cloud. So at a high level, ADF is more of an orchestrator, while integration services is more of a data flow and an execution tool, where ADF is more of the scheduler and does the orchestration. There is quite a bit of crossover. There are some things that integration services will do that ADF will also do, and vice versa. But in my experience, there's more that there are more ways that they differ than how they are alike. So on the integration services side, again, if you're on this webinar, you've probably worked with integration services at least a little bit before. It's a fairly familiar ETL tool. It's got a relatively easy to use UI. And for conventional load processes, if SQL Server is installed, it's absolutely the way to go. On the flip side, ADF is an orchestrator that runs entirely as a cloud service. Get ready to write some code, because while there is sort of a UI for ADF, there's going to be much more coding required on UI because it's less UI centric and more code based. You're going to write a lot of JSON code, for example, to do that. If you're doing if you have transformations or data flow needs where you don't have SQL Server installed, if it's purely an in the cloud load scenario, this can be an option. I'll say this as gently as possible. There's some features that I like about ADF. I look forward to it maturing into a more usable tool. I think right now it's got a fairly limited set of uses. But I think with the options that we have on on-prem and virtual machine SSIS, and especially on ADF v2 where we can actually run SSIS packages in the cloud on ADF, I think that will open up Azure Data Factory to even more business scenarios that can use it. Version 2, it's still in preview. It shows a lot of improvements, not a lot of UI improvements necessarily, but some functionality improvements. And again, from my perspective, being one who prefers SSIS as an ETL tool, the fact that ADF version 2 has a runtime for SSIS that lets you deploy packages out to integration services in the cloud. That's the most promising new development in integration, or rather in Azure Data Factory, is allowing SSIS packages to be run there. So finally, running SSIS DB or SSIS on Azure DB. That's a little bit of a misstatement because technically it's running on ADF. It's running on Azure Data Factory. The way it manifests itself, though, is it looks like it's running on Azure DB, and I'll show you what I mean once we get into the demo portion. So this new feature lets you take your SSIS packages, run them in Azure Data Factory. There are some pretty strict limitations on what you can do with that. Specifically, at least the last time I checked, they may have opened this up, but as of just a couple of months ago, if you set this up to run, if you set up an Azure Data Factory to run as an SSIS runtime, it had to be on US East, or I believe there was one other region that would allow that. It wasn't every region that would allow that. So make sure that if you're going to set this up that you check the documentation. I just make mine as US East. I'm technically Central, but it's close enough that I know that will always work, so that's what I've relied on in the past. This will let you programmatically, and I want to emphasize programmatically, not UI, build a data factory and allow that to accept SSIS packages. You can deploy SSIS packages to that runtime and then execute them from there. Interaction is almost identical to your on-prem integration services server. When you connect to your Azure DB database that's running integration that's exposed through that ADF runtime, you'll see your SSIS DB database. You'll see your integration services catalogs node with the SSIS DB node below there. You can execute your packages. You can check your logs. You can run your Management Studio reports just like you could on a deployed local version of integration services. A few limitations. Again, the biggest one is that there's no UI, so you're writing quite a bit of code, mostly PowerShell code. And I'll show you a little bit of that code. I don't want to scare you off from that because there is some sample code available. In fact, all the code that I'll show you will be available as a download, but most of what I got, I adapted from some Microsoft examples that were online. So you don't have to write the code yourself, but it does require a little bit of PowerShell coding to do this. One of the big limitations is that you can't use custom or third-party applications. So if you're using that little trick that I showed you earlier about communicating with an SFTP server, you won't be able to use a third-party tool for that. So if anything requires a third-party tool, a customized DLL or something like that, for right now you can't do that in the Azure DB or ADF version of integration services. And then finally, scheduling will absolutely be a challenge. For your in the cloud databases for Azure Sequel Dw, there is no SQL Server agent that will let you run SSIS packages. So if you want to schedule them, your options are fairly limited. You can schedule them through Azure Data Factory, which is definitely a challenge. If you're going to schedule a job that's deployed to Azure Sequel Dw or ADF, probably your best bet is to schedule it for right now. Schedule it from another machine, either a VM or an on-prem machine that is running a full version of SQL Server, and use the SQL Server agent to execute a T-SQL script to go out for that. So I'm hopeful that we'll see some scheduling changes. That really is, I should have put that at the top of the list, that really is a severe limitation on SSIS on ADF, but do be aware that it's out there. There are some workarounds, but they are absolutely workarounds and not native solutions to the problem. All right, with the slides out of the way, let's jump in and I'll show you a few demos. First one that I'm going to show you is simply an on-prem package that communicates with cloud data sources. So I've got a package that I built here. Let me zoom in. I'm not sure what the resolution will look like on the presentation. So I've got a package here that reaches out, executes a truncate statement on my sales transaction table. I'm using a for each loop container to load data to an Azure SQL database. And if I double click in there, you can see that I've got just a conventional flat file source writing out to an OLEDB destination sales transaction table. And if I open that up, that's using not an on-prem data source, it's using my SQL DB that resides in the cloud. But apart from that, everything looks exactly the same like I would run as an on-prem load. So from Ssis's perspective, if I'm using the OLEDB driver, it doesn't see this as, hey, this is a cloud data source versus an on-prem data source. All it cares about is this is an OLEDB endpoint and I'm going to send data to it. And that's really the only thing that Ssis cares about. The only way that this package would differ from any other one, make sure that I'm getting the right one, SQL Dw. The only way that this differs from any other package that I would run is instead of connecting to a local server name, I'm connecting to and then the cloud server name. In this case, this is the instance that I'm connecting to. Here are my credentials. So I could have set up Windows Authentication if I wanted to go through that exercise just to keep things simple. I set it up as SQL Server username and password. And then down below here, this is the database to which I'm writing. So from that perspective, from that perspective, Ssis really doesn't care that it's an in the cloud database. It's just another database that it's writing to. So when we execute that, looping through that series of files, we should see a couple of different row counts passing through, one for every file that we load. And again, apart from just pointing to an Azure SQL DB as opposed to an on-prem database, this package works identically to anything else that we would wrangle. Now, I've done this using a local data source as or local set of data as the source in that flat file, and then a remote set of a remote connection, a remote table to write that data to. There's nothing to say that you couldn't communicate from cloud source to cloud source. Do be aware, though, that if you are communicating from one cloud source to another, if you're writing from, say, a SQL Server Azure or Azure SQL DB instance on the source side, another Azure DB on the destination side, from a memory management perspective, if you're running that package on-prem, what has to happen is it's going to take that data from the source, bring it down to your on-prem Ssis server, and then push it back up to the cloud. That's not necessarily a bad thing. But if you've got either an extremely large set of data, or maybe you have a slow WAN link where connecting to those data sources is a bit slow, that can be a bit challenging because you're basically forcing the data to hop across a couple of different hops, one of which is coming down to your on-prem Ssis server and then going back up to another server. So do be aware of that performance, potentially performance impact. But for a case like this where I'm working purely from a local file, maybe it's a flat file like this, maybe it's a JSON file, a set of files, or an Access database. Running an Ssis instance on-prem is absolutely the way to go. It's certainly the simplest way to set that up. And as you can see, for the most part, Ssis really doesn't care that that was a cloud destination. It's just writing out to some database that you define. It'll look a little bit different if I'm running two cloud connections. And as far as the setup, it'll be identical, but the performance will absolutely be something you want to pay attention to. I'll show you what that looks like in a second. Same setup that we had before, truncate my destination table that we're writing to. Over on my data flow, I'm reading data from a sales transactions table, writing it to a sales transactions table. Each one of those is a cloud endpoint, but it's a different cloud endpoint. So this one is pulling from, excuse me, this one is pulling from my SQL Dw that we were dealing with just a minute ago. This one is writing to sales DW. So this is a different table and a different SQL instance entirely. So as you can see, the first one that we ran actually pretty quickly. But when I run this, what's going to have to happen is it's going to pull from, on the left side, that's my source. It's pulling from that cloud source, bringing the data down to my machine here in the Dallas, Texas area. It's going to take that data from here, push it back out to the East Coast where that destination server lives. Now that didn't take extremely long amount of time, so it took about 9 seconds to push across 11,000 rows. And this is a pretty flexible way to handle it because that on-prem SSIS server really becomes the gateway that we're using. Again, the potential downside is if there's a slow link involved or if there's a very large volume of data, that's going to be a potential slowdown because in most cases, if I'm communicating from cloud to on-prem back to cloud, that's going to be a bit slower than simply going from cloud to cloud data source because there's no need to make that trip down to my on-prem server. So that's what it will look like if it's running on-prem. For the most part, if we're running that same operation in an Azure VM, it's going to look almost identical to it. The only difference is that if I excuse me, if I have multiple connections where I've got my SSIS server running on instance 1, I'm using instance 2 as my source, instance 3 as my destination. I do have to be aware of how performance and how quickly the data is coming across. But if I'm running that purely in the cloud, and especially if I'm not already running an SSIS server on-prem, running this in the cloud absolutely could be the way to go. This does require, as I mentioned during the slide deck, it does require that you configure and monitor and maintain that Azure VM running in the cloud. But there can be some advantages to that from a cost perspective. You can run this on an hourly basis. There is a feature built into provisioning a VM that if you're provisioning a SQL Server VM, you can base that or have that license be based on not simply purchasing a license outright, but running that only for the amount of time that you're actually running it. So if you do something like that where you're running your SSIS VM only during the hours of, let's say, your ETL windows from midnight to 6 a.m., if you're paying for a midnight to 6 a.m. license versus a 24-hour license, you're going to save quite a bit of money because you're not paying for the hardware and the licensing and the consumption costs around the clock, but only for that window that you need it. And the easy part of that is, as I mentioned earlier, the management from that perspective. If you're running this in a VM, I am actually running this in a VM, but it's not an Azure VM. But from that perspective, it would look almost identical to what you would have on-prem. Let me get the right connection here. So this on-prem version would look almost identical to the one that you're running in the cloud. You're going to have your Integration Services catalogs collection. You'll have your catalog in there from the database itself. You're going to be backing up this database, monitoring this database. So the learning curve and the administration curve is much easier if you're running that as a VM in the cloud, if you're already used to running it as a regular service on-prem. So that's a couple of examples of using SSIS either on-prem or in the cloud to connect from on-prem data to cloud data or from cloud data to cloud data. The one example that I won't show you, and this is one that I mentioned a little bit earlier, is that if you're running SSIS in the cloud, either as an ADF service, which I'll show you in a second, or in a VM like we were just talking about, if you're reaching back into your on-prem data sources, setting up that connector, either the virtual network or VPN, that will be a challenge in itself. It's not necessarily a hard thing to do, but often it will require the expertise of some network folks from your organization to get that set up so you can, in a secure way, reach out from cloud SSIS back into on-prem and either get or write the data that you need from there. All right, so that's the basics on integration services on running either in the cloud or on-prem in an install version. Let's talk briefly about some of the connectors that you have whenever you install your Azure feature pack. So I'm on the control flow right now, showing all the control flow pieces that we have available. Scroll down with me for a moment on my toolbar over on the left side. You can see that I've got, when I install, pardon me, when I install that Azure feature pack, I've got a number of new tools that I can use that are available here. If you don't have this installed, you'll still see that Azure folder or the Azure virtual grouping, but you won't see any of these assets below there. some of the things that we have available to us. The ones that I use most often are Azure Blob Upload and Download. If you're using either HD Insight or Pig or Hive, you can use some of those tasks to be able to kick those off, create a cluster, delete a cluster. And for those who are using Azure Sequel Dw, there's an upload task for that as well. If I jump over to the data flow side, go back to my toolbox, you can see that on the data flow side, there are a couple of components on there as well. Azure Blob Source, Azure Blob Destination, and if you use Data Lake Source and Data Lake Destination. So you could do most anything that you needed to do on those cloud assets without having to use those connectors, but trust me, if you're connecting to any of those pieces, using Pig, you're using Hive, you're accessing Hadoop, creating clusters, it's going to be a lot easier if you go ahead and download that free tools pack and use that. I won't show you all those, but I will show you a brief example of one of them. Let me fold this one up, go into my next project. Sorry, it's that one. I'm going to go ahead and do the Azure Blob upload. Double click on that. So some of the assets that we have here, we need to specify as a connection, the storage connection that we're using, the container for the local directory if I'm uploading files here. If I want to specify a filter, I can get the time range from and time range to. So I've already set those up. I'm going to briefly jump over to my Storage Explorer. This is a free tool that you can use to see. You could do this through the portal as well, but I'm a fan of, if I'm browsing files, I want to have a friendly UI for that. So I'm going to delete the ones that I had previously created. So I've got my blob container over here that's called test. Hopefully that shows up okay on the presentation. Right now that one's empty. So I'm using the Azure Blob upload task to upload all those JSON files that are in that specified directory. Let that run for a second. It doesn't take very long. And now if I refresh, now that's uploaded all 4 of those files. And that was all done using a native component of SSIS. Again, it was one of the add-on pieces that came with the Azure feature pack, so do be aware that you do have to have that. But if you are interacting with anything blob-related uploads, downloads, or doing something with either sourcing or writing data to an Azure DW, make sure that you download that feature pack because it doesn't take long to download. It runs on the client side. It doesn't have to be installed on the server. And it will certainly save you a lot of time. So very quickly, I'm going to show you a couple of scripts that I've got. You don't have to worry necessarily about sketching these down. I'll make them available as downloads for managing this. So I've got a list of PowerShell scripts that I use for various things. One of the things that I'll use PowerShell scripts for is if I'm scaling out integration services and I want to spin up multiple VMs at one time. Let's say I have my ETL window from midnight to 6, like I mentioned earlier. I only want my ETL VMs to run during that time. So what I can do is create a script that will start my Azure VMs. I can run this on a schedule, on whatever scheduler I want, whether it's SQL Server Agent, Windows Task Scheduler, or whatnot. Spin those virtual machines up as I need them, and once my ETL operations have finished, there's a separate script to be able to spin those down. So start Azure RMVM and then stop Azure RMVM once those are done. We're not going to wait around for that to complete, but I will show you that all I have to do to invoke that is, if I'm doing it interactively, simply go out and execute that script using PowerShell. I wouldn't want to do this manually unless this is a one-time thing. If it's a nightly process or a weekly or monthly process, I'm going to script this out and then schedule it so the script runs automatically before my ETL runs. The shutdown script runs automatically afterward. But these scripts will be available for you if you want to play with those a little bit later. The last thing I'll show you, and this is the one that I'm most excited about when we talk about SSIS and the cloud playing well together, is the ability to have integration services running actually as a PaaS offering in the cloud. So right now you can run it in a VM, just like we were talking about earlier, but it does require that you set up a VM, you install SQL Server, you go through that whole exercise. If you don't want to run SQL Server, if all you want to have is just the SSIS runtime, starting with Azure Data Factory version 2, you can now do that. It does have a few caveats. As I mentioned earlier, it doesn't have a nice UI. It does require some scripting, and it does have some limitations on the third-party tools that you can install there. But this is a great first step in integration services. So I'll walk you through that briefly. And to do that, I'm going to have to show you one more script. I don't claim ownership over most of this script. This was actually an adaptation of something that Microsoft had published when they first released this as a preview. But there's a script that you can use to set up to connect to your Azure Data Factory, or rather to your Azure subscription. Create an Azure Data Factory runtime in integration services. Mark that as active, so it's ready for processing. And then it opens that up to allow you to deploy SSIS packages and execute SSIS packages from that. I'll not go line by line through the script. Again, you can download this and modify it or play with it as you see fit. But effectively, once I connect to my subscription name, I've got a number of variables set up to say I want to name my integration runtime with SSIS IR, give it a description. It has to run, at least right now, it has to run in East US. I'm setting that for the lowest level, which is standard A4 V2. Pass in my username and password, which are conveniently redacted there for the purposes of presentation. And then once I've got that set up, I'm going to use those variables, log into my account, set up a new Azure Data Factory V2 instance, set that Azure Data Factory V2 instance to an SSIS runtime, and then I'm going to kick that off. Now, one of the things that I'll point out here is once you start that using this function, start RM Data Factory V2 integration runtime, that takes a little while to spin up. It takes as much as 30, I've seen it take up to 40 minutes to run. So there's a note in here that you're going to see when you run this script saying, hey, this script is going to take a little while. So if you're doing a presentation, you want to do this well in advance, but do be aware that that does take some time. I've already run that, so we're not going to wait around for that. The result of that is if I jump back over to, let me disconnect here, and then I'm going to make one more connection to my SSIS cloud database, shift over to my options. Bear with me 1 second here. So now what I'll see is you saw that I changed the database. I'm just connecting to the default database. I'm calling this instance SSIS Cloud. And I've got my list of databases and my security tabs. This is what I would normally see whenever I have just a regular instance of SQL Server. And you can see that the only database that we have on there is SSIS DB. But I really don't have, using this interface, I really don't have a good way to tell me for sure that SSIS is up and running on this machine. What I have to do is, and this is what I did on the other connection, is, pardon me, whenever I connect to that, instead of connecting using the default database, if I actually connect to SSIS DB, the interface will look a little bit differently. So that's what I did on the above connection, and you can see that it looks a little bit different than the previous one. I still have my list of databases, but now I have a list of integration services catalogs as well. Pardon me. So if we were to look back through that script, what I'm connecting to on that Azure Data Factory runtime is that I'm effectively attaching that ADF runtime to that SSIS cloud instance that I had previously provisioned. And what that allows me to do is it allows me to run integration services. I'm going to see that integration services catalogs node just like I would in an on-prem execution. I've got my one SSIS DB that was already created. I've got my folder that I'd already created here, my list of projects. I've only got one project. I've only got one package in that project. But from here, this is, for all intents and purposes, just a regular instance of the SSIS catalog. So if I right-click and go to Execute on that package, I can go ahead and click OK. This interface will look just like it always has. So I've got, if I had any parameters, those would be exposed here. I can change my connection managers. I can go to Advanced. I can change my logging level. Let's say I want to use the verbose logging level. Click OK, and just like it does for an on-prem SSIS installation, it asks me, do you want to open the execution report now? I'm going to click OK. I do want to see that report. That's probably going to run for about 20 seconds or so. The package, not necessarily the report. And you can see my most recent executions here. So I ran this a little bit earlier today. It did succeed. You can see that I had a failure a little bit earlier in the same day. And if I widen out that filter just like I can do as an on-prem installation, let's just take that back a full year. This will show me my full history of execution on those SSIS packages. Now again, this is not a full-featured installation of SSIS. I can't run custom components. Scheduling is challenging. If you remember from the UI back on the left over in the Object Explorer, there is no SQL Server agent, so I can't schedule this in the same way that I can a normal package. But as far as that goes, for a first step in moving SSIS packages to the cloud, this is a fantastic first step, and I definitely look forward to, once this is a fully anointed and fully working version, right now it's still in preview, once this is fully working and it's actually released for general consumption, I'm hoping that we'll see some more of those features, like the ability to use third-party tools, like the ability to easily schedule without having to jump through those ADF hoops that we would normally have to jump through. So that's the most exciting thing as far as integration services in the cloud. Again, that last piece is still emerging. It's still a bit pliable, but I look forward to, once it's released into the wild as a properly working non-preview service, I look forward to what they'll have on that. A couple of things that I've linked on there. If you want to deploy packages to Azure, that code sample that I mentioned earlier, it was largely drawn from information on that first link, and that Azure feature pack for SSIS is the second link, and that's a free download. We'll open it up for questions now. I'll put my contact information on here, my email address, tylers.com if you need professional help on your integration services or data warehouse. And then if you want to keep in touch with things that I do or various announcements, I have a newsletter that I put out every other week at timmitchell.net/newsletter. So Jason, I'll pass it back over to you for any questions that we have.
Great. We've got a few questions here. The first one it's the last one that came in, but I'm going to answer that one right away. The question was, is this session recorded? Yes, it is. And usually it takes me about between a couple days and a week to get the sessions up. Now the rest of the questions will be for Tim. So the first one, when you are pushing data into Azure SQL and the source end of the SSIS is on-premise and there's no common AD configured, what are the authentication options and what DB roles are needed to update and add data to tables in Azure DB in an elastic pool?
So take out the elastic pool part of that, and really if you're just writing to an Azure Sequel DB, having DB or data reader, or rather data writer, is really the only thing that you would have to have in there. Or if you want to have table specific, just like you can with an on-prem installation, if you want to give table specific permissions, you can do that without granting a broad role. With the elastic pool side of it, though, I don't know that would change the permissions that are required. I don't know that it doesn't for sure, but honestly, I haven't worked with elastic pools in that. I think the answer would be the same for an elastic pool, but really that's going to be it, is either having that global data writer role or having object-specific permissions.
All right. Can you use ADF for orchestration to call SSIS packages?
Can you use ADF orchestration to call SSIS packages? The short answer is yes. I'm going to read into that. Can you call them through the ADF runtime? The answer is also yes, because if you're executing an SSIS package, ultimately that's just a T-SQL statement. So whether it's ADF scheduling, whether it's the SQL Server agent, whether it's a Windows scheduler, if you're executing an SSIS package either on-prem in a VM or in ADF v2 in that Azure runtime, or that ADF runtime, it's just a T-SQL statement that you're executing. So yes.
Oops, sorry about that. I moved myself apart. Sorry about that. So next question is, with a VM on the cloud, will SQL Server Agent run?
Good question. If you're running a VM in the cloud, will SQL Server Agent run? Absolutely. So because you have a full running version of SSI, or rather a full running version of SQL Server, all the on-prem attributes will still work. In fact, it looks just like, to SQL Server, it looks just like an on-prem installation, except that it's running in a VM in the cloud instead of on-prem. So yes.
All right. And a couple more came in. With SSIS and ADF v2, what about the use of checkpoints?
Great question. What about the use of checkpoints? I haven't modeled out checkpoints in ADF v2. I'll be honest, I don't use SSI's checkpoints a lot, even in on-prem development. They're challenging enough on-prem. So honestly, I would probably avoid them even more so than I avoid them on-prem in ADF v2. But for a very simple answer, I haven't used them, so I don't know all the downstream implications of that. Using the checkpoints does require access to the MSDTC, and because you're not really running on a machine, you're running on a platform as a service, I suspect that checkpoints would be even bigger of a challenge in the paths setup on SSIS.
Great. Okay, we have time for one more question, and the question that we got left is, can we use ADF polybase option to load data from an on-prem to Azure Sequel Dw without the need for blob storage?
Say that one more time, sorry.
Sure. Can we use ADF polybase option to load data from on-prem to Azure SQL Data Warehouse without the need for blob storage?
So that's really stepping outside of using integration services. That's really focusing on the polybase side. I haven't used polybase much at all for loading data, so I'd have to say I don't know on that one.
Yeah, and I'm looking at this because I used to do a lot with polybase, and I don't think you could get around that unless they've added more into polybase that allows you to bypass the storage option.
Yep.
But my information is a little bit dated. All right. Well, great, Tim. Thanks for joining us for this session today. You are welcome to come back and talk Azure topics at any time in the future. As I mentioned at the beginning, I'm looking for lots of topics. So
sounds good.
Anytime.
I had a lot of fun. Thanks everyone for attending.
Yes, thank you everyone, and good day.